Python 2, different meaning of the in keyword for sets and lists. Consider this snippet. Which evaluates 2. Can anyone explain why the in keyword has a different meaning for sets and lists? I would have expected both to return true, especially when the type being tested has equality methods defined.
The meaning is the same, but the implementation is different. Lists simply examine each object, checking for equality, so it works for your class. Sets first hash the objects, and if they don't implement hash properly, the set appears not to work. Your class defines _EQ_, but doesn't define _hash_, and so won't work properly for sets or as keys of dictionaries. The rule for _EQ_ and _hash_ is that two objects that _EQ_ as true must also have equal hashes. By default, objects hash based on their memory address. So your two objects that are equal by your definition don't provide the same hash, so they break the rule about _EQ_ and _hash_. If you provide a _hash_ implementation, it will work fine. For your sample code, it could be
in pretty much any hash table implementation, including Python's, if you override the equality method you must override the hashing method. In Python, this is _hash_. The in operator for lists just checks equality with every element of the list, which the in operator for sets first hashes the object you are looking for, checks for an object in that slot of the hash table, and then checks for equality if there is anything in the slot. So, if you override _EQ_ without overriding _hash_, you cannot be guaranteed that the in operator for sets will check in the right slot.
Define _hash_ method that corresponds to your _EQ_ method. Example.
Ya udah selesai Loren, ya sekarang sudah selesai.